Welcome to Summarize Science, where today we are looking at how robots are learning to handle the heat. Developing robots for dangerous environments like structural fires or industrial accidents is incredibly difficult because real-world testing is far too risky and expensive. Most current robot simulators are excellent at simulating movement and solid objects, but they often ignore the complex behavior of fire. In typical simulations, fire is often treated as just a visual effect, like a moving texture or a simple particle system. This means a robot in a simulation might see flames, but it won't experience the actual heat radiation or the way smoke realistically chokes a room. To solve this, researchers have introduced a framework called Fire as a Service, or FaaS. FaaS is a clever system that connects existing robot simulators with a high-fidelity fire simulation engine. By separating the fire calculations from the robot's own controls, the system can provide complex physics without making the simulation lag. This allows robots to experience multi-species thermodynamics, which is a fancy way of saying they can sense different gases and heat levels. The system uses a specialized engine called FireX to calculate how flames spread and how heat radiates through a 3D space. Importantly, the fire reacts to the environment, meaning smoke will hit the ceiling and expand, and heat will be blocked by walls or objects. Robots are equipped with virtual thermal sensors that allow them to feel the temperature rising as they get closer to a hazard. In one experiment, a robot was tasked with navigating a room where a fire was burning behind a wall. Even though the robot couldn't see the flames through the wall, its thermal sensors detected the heat radiating through the window. This data is then used to create a cost map, which helps the robot plan a path that stays a safe distance away from the danger. The research team tested several different path planning strategies to see how the robot would react. When the robot was told to prioritize safety, it chose a much longer route that circled around the heat sources entirely. This level of physical accuracy is vital for teaching AI how to make life-saving decisions in a split second. They also used a technique called behavioral cloning, where a human operator drives the robot through the fire first. The AI then learns from the human's movements, eventually figuring out how to navigate toward a goal while reacting to heat sensors it can't even see. This proves that robots can learn to avoid invisible hazards using only thermodynamic data. In another test, a reactive controller was used to steer the robot away from sudden heat spikes in real time. As the robot approached a fire, its sensors pushed it away, much like a magnetic field, ensuring it never got close enough to be damaged. The system proved to be robust even when there were slight delays in the simulation data. To recap, Fire as a Service bridges the gap between looking realistic and being physically accurate. It provides a way to train robots for the most dangerous jobs on Earth without putting any real hardware or people at risk. This technology means that the robots of the future will be much better prepared for the unpredictable nature of fire. In the future, this work could expand to include how fire actually damages materials and causes buildings to degrade. It could even help robots learn to see through thick smoke by using specialized gas sensors. Thank you for watching Summarize Science, and stay tuned for more breakthroughs that are shaping our future.